Okay, so this is the notes on reflections. So reflections are the second type of transformations we are talking about. First type of transformations was translations. Okay, translations move the figure vertically or horizontally, or a combination of both. Reflections are the second type. So reflections is a transformation. So transformation. Okay, that uses a line like a mirror to reflect an image, okay, or an object, or a geometric figure. Lots of different words we can put into this blank here. Okay, we're going to say an image, so we're going to reflect an image. Okay, a reflection is an isometry. Okay, if you remember, isometric figures are figures that are basically congruent. So when we do our transformation, pre-image and the image are going to be the same. So the before and after are going to have the same size. They're not the same. They have the same size and shape. They're congruent. Okay, so it's isometric. All right. Let's go to the first four. There's really five or it depends how you classify it, 5 or 6 different categories. But the four where we're going to actually have like rules for are all found here. So let's write the rules in first, and then we'll go through each one. Okay. So if we're reflecting across the x-axis, so if the point AB is reflected in the x-axis, its image is the point A negative B. Okay, AB goes to A negative B. Right. For y-axis, if AB is reflected in the y-axis, its image is the point negative AB. This is going to be a struggle. We may not finish. I will try. Okay, so AB is reflected. So AB goes to A. If we write it a different way, AB goes to A negative B. Here, AB goes to negative A. Okay, so you're just flipping the sign on the first one. Okay, and then the other two we have with the rules are reflection across the line y equals x and reflection across the line y equals negative x. So this one is going to be AB is going to go to BA, so we're going to switch the two values. Okay, so in this blank you should have BA, and then over here AB is going to go to negative B, negative A. Okay, so this blank should be negative B, negative A. But let's look at the practice examples here. So let's go back to the first one, reflecting over the x-axis. I'm going to write the rule up top here. So if you remember, AB is going to go to A negative B when we're reflecting across the x-axis. Okay, so first point we have here is 4, 2. So that's this point here in red, 4, 2. If we use our, so the idea of reflecting is that we're going to be flipping it over the x-axis. So this is our x-axis right here. Okay. We're going to be flipping it over, reflecting it over the x-axis. Okay, think of it as folding a paper in half. So here we have a sheet of paper, you have a point B on it. Okay, when we fold it in half, okay, and this half top is going to come down, B is going to come down and land right, or this point is going to come down and land here, right? So this point was 2 points above the x-axis. It's going to reflect down to 2 points below. So imagine folding it down. It's going to reflect 2 points below. Okay, if we can't do that visually, if it can't reflect it visually, we can use our formula. So 4, 2, okay, is going to go to A is 4, so 4 stays 4. 2 becomes negative, so we get negative 2. And this point here is 4, negative 2. Okay, 6, 1. So our negative 6, 1 is this point right here. Or actually, it's off the graph a little, so it's over here. We want to reflect over the x-axis. So again, imagine a sheet of paper, we're folding the top half down. Okay, so that point's 1 above the x-axis. It's going to end up being 1 below. That's negative 6, 1. Or negative 6, negative 1. Okay, or we could use the formula again. Negative 6, 1 is going to go to negative 6 stays the same. And we flip the sign on the other one. So we get negative 6, negative 1. Okay, and the last one here is negative 2, negative 4. Want to reflect over the x-axis. So again, it's like folding up. Okay, so it's 4 units below. It's going to end up 4 units above, which is going to be negative 2, positive 4, which again fits our equation. So our equation says AB goes to A negative B. So 4 goes to 4. Negative 6 goes to negative 6. Negative 2 goes to negative 2 because A goes to A. And here we have 2 goes to negative 2. 1 goes to negative 1. Negative 4 goes to positive 4. So we're flipping the signs. That's because B is going to negative. We're flipping the sign. So X would go, so 4 goes to 4, negative 6 goes to negative 6, negative 2 goes to negative 2, so X is going to go to X. 2 goes to negative 2, 1 goes to negative 1, negative 4 goes to positive 4, so Y is going to go to negative Y. So any point XY is going to reflect to X negative Y. The second one, we're reflecting over the y-axis. So if we remember our formula, okay, it's AB goes to negative AB. Okay. So our point 42. So this time, this is our y-axis. So instead of folding it up down, we would fold it right left. We're reflecting right left. Okay, so the point 42 is right here. So it's 4 to the right, so we need to reflect it 4 to the left. Again, if you imagine folding this over, right, it's going to line up perfectly. Okay, or you can use the formula. So we're switching the sign of the x value, the first coordinate, right? A goes to negative A, so 4 goes to negative 4. B goes to B, so 2 goes to 2. And we see this is 4, 2. This is negative 4, 2. Okay. All we're doing here is changing the sign. Negative 6, positive 1. So this is negative 6, positive 1. And all we do is flip. A goes to negative A. So negative 6 goes to a negative times negative 6, which is a positive 6. Right? We're just flipping the sign. B goes to B, so 1 goes to 1. So negative 6, 1 goes to 6, 1. Again, that makes sense because we're reflecting it over the y-axis. So this is 6 points away from the y-axis. This one is also 6 points away. It's just getting flipped over, reflected over. Okay, last one is negative 2, negative 4. Again, we're going over so this is negative 2, negative 4. Again, we're reflecting over the y-axis, so it's got to be over here somewhere. Okay, we can use our formula. So negative 2 goes to negative A, or A goes to negative A, so negative 2 goes to the opposite one, which is going to be 2. And then negative 4 stays negative 4. Okay. And, right, A, so we're flipping the sign. 4 goes to negative 4, negative 6 goes to positive 6, negative 2 goes to positive 2, which means X is going to go to negative X. B goes to B, so Y is going to go to Y, right? 2 went to 2, 1 to 1, negative. Okay, then we're going to reflect over the line y equals x. Okay, so here's our line y equals x, right? Lines are in the form of y equals mx plus b. Okay. We have the line y equals x, which is the same as y equals x plus 0. So our y-intercept is 0. And then our slope here is 1. Right? So we have a line y equals x. Okay, let me put this back. So we're reflecting all the points across this line y equals x. Okay, our formula again was AB goes to maps to BA. So we're basically just flipping the points. First one is 4, 2. Okay. And visually, right, we're going to fold it this way. Right? We're reflecting this way over the line y equals x. So visually, we can see it's here, which is going to be 2, 4. Okay, or we could use our formula. So AB is 4, 2. Okay, so A is 4 and B is 2. Okay, so we put our next formula in. We got BA. So B, we said, was 2. And A is 4. So all we do is flip the order. Okay. 4, 2 becomes 2, 4. Okay, negative 6, positive 1. It's right here. We're going to flip it down here, so it should be 1, negative 6. Okay, folds over. Okay, just flip them. AB, BA. Okay, and then we have negative 2, negative 4, which is then going to go to negative 4. Negative 2. Right, and then we know any point x, y is going to become y, comma, x, right? So all we're doing here is flipping the points. Changing them all. Okay. Next one reflects, so next one is y equals negative x. So let's draw in our line y equals negative x. So y equals negative x has a slope of negative 1 and a y-intercept of 0. Not the best line here. Start over. Okay, so that's our line y equals negative x. Okay, so our formula for y equals negative x is AB goes to, maps to negative b, negative a. 4, 2. Okay, let's just use our formula. So 4, 2 is going to go to negative 2, negative 4. These ones are hard to visualize, right? But it would be somewhere down here. Okay, because you got to think of folding it over, reflecting it over, so it should be symmetric. Or our formula says AB goes to negative BA, so we have to switch them, and then we have to make them negative. So A is 4, right? If we have 4, 2, right? A is 4, B is 2. So we want negative B, negative A, so we want negative 2, negative 4. Right? We're just flipping them and making them negative. All right. And same thing with the next one. Negative 6, positive 1 is going to become negative 1, positive 6. So negative 6, positive 1 is going to become negative 1, positive 6. It's just reflecting over this line. Again, if you fold this in half, these points should match up. And then the last one's negative 2, negative 4. Okay, which is the same one where we ended. Flip it back over. We want to flip them and flip the signs. That's going to become positive 4, and positive 2. Okay, this is negative y, negative x. So fold it over, the point should match up. So here we have 4 practice problems then. Okay, the note sheet. So here we're reflecting over the line y equals x. So let's draw in our line y equals x. So again, y equals x has a positive slope of 1 and a y-intercept of 0. So that's our line y equals x. We have the point 0, 4. And we want to reflect it over the line y equals x. So again, it's like folding it over. So it should end up somewhere over here. Okay, our formula for reflecting over the line y equals x is that AB, so the point, okay, is going to go to BA. So we're going to basically swap the coordinates. So 0, 4 is going to go to 4, 0. 2, negative 2 is going to go to negative 2, 2. And negative 1, 3 is going to go to 3, negative 1. The x coordinate becomes the y coordinate becomes the x coordinate. Okay, and we can map all these. So negative 1, let's map all the original ones first. So 2, negative 2, and then 3, negative 1, 3. So here's your original. Okay, and then our flipped one is going to be right. So if you look, it's going to be symmetric on both sides. So if you flip this side down, it's going to match up perfectly with that side. Okay, next one, we want to reflect over the line y equals 1. So this is not one of the ones we had a formula for, so we just have to count and use the visual, our visual for vision. Okay, so we want to write the line y equals 1. Okay, so the line y equals 1 is right here. So that's what we want to reflect over, this line y equals 1. Okay, so we look at our point, negative 1, negative 1. We notice that it is 2 units below the line y equals 1. So if we reflect it over, it's going to end up being 2 units above. So 1, 2, 2 units below, we need to flip it 2 units above, 1, 2. So that's going to become negative 1, positive 3. Then we have the point 1, 0. That is 1 unit below the line, so we need to flip it 1 unit above, which makes it the point 1, 2. The last point here is negative 2, 3. That's 2 units above the line y equals 1. We want to reflect it below, so it's 2 units above. We need to reflect it 2 units below. Let's put it right here, and that coordinate is negative 2, negative 1. The last 2 examples. We want to reflect over the y-axis, the x-axis, I'm sorry. So our x-axis is right here. X-axis. Let's start with the 0.45. So our formula to reflect over the x-axis is AB goes to A negative B. So 4, 5, or we can think of it as being 5 above, so now we need to go 5 below. Okay, or we can plug it into the equation, so 4, negative 5. Okay, next point is negative 1, 0. That's on the line, so it's going to stay negative 1, 0. Again, if we imagine folding this over, all the points on the top should match up with the points on the bottom. So negative 1, 0 is on the crease. So when you fold it over, it's going to stay on the crease of the fold. So it's not moving, it's staying the same. Now our last point here is 1, negative 4. Okay, we're going to flip it over, reflect it over the x-axis. It's going to become 1, positive 4. Right, so again, all of these we're just changing, right? 4, negative 1, and 1 stay the same. And we're changing from B to negative B. So 5 to negative 5, 0 to negative 0, but negative 0 is just 0. And then negative 4 to positive 4. Right, negative 0 isn't really a concept. All right, last one. We are reflecting over the line y equals negative x. Again, that's our line with a slope of negative 1 and a y-intercept of 0. Our formula for reflecting over the line y equals x is AB goes to negative b to negative a. Okay, so 1, 2. It's going to go to flip them. So 2, 1, and then make them negative. Negative 2, negative 1. 2, 0. Flip them, change the signs. So 0 is going to stay 0. Negative 2 is going to become positive 2. Here we have 1, negative 4. So flip them. That's negative 4, 1. Change the signs. Negative 4 becomes positive 4. 1 becomes negative 1. So 4, negative 1. The original was 1, negative 4. Right? So it flips over, flips over. Our last one was negative 2, 0, 2. All right, so it makes sense. Whoops. I think it's this one. So those are the notes on reflection.